because I'm a very biased person, I'm going to dedicate this short video only for acetyl coenzyme A. Not just kidding. But, with jokes aside, acetyl coenzyme A is a very important precursor or an intermediate, so to speak, in several metabolic pathways. Well, as we would discuss in another video, acetyl coenzyme A, of course, is very essential in the TCA cycle or the Krebs cycle, wherein the first step it undergoes is combination with oxaloacetate to form citrate. Alright? But in addition to that, acetyl coenzyme A can go to several other pathways. For example, two related pathways, and I say related because they produce the same class of biomolecules. Two of these have acetyl coenzyme A as its starting material, and by these two, I'm referring to two classes of lipids. The first one is the steroid type of lipid synthesis, and the second is fatty acid synthesis. Alright? In the steroid synthesis, what actually happens is that you combine 3 moles of acetyl coenzyme A to produce, how many carbons are that? You have 2 carbons here, so 2 times 3 equals 6. Alright? The name of that compound is hydroxymethyl-luteryl coenzyme A, or HMG CoA, which would then undergo reaction to come up with what we know as mevalonate or mevalonic acid, which is a 5-carbon compound. And in a series of steps, the 5 carbons will become 10, then it will become 15. I know the names, but I won't mention them anymore. It's not essential. Then it will become essentially a 30-carbon compound known as squalene. But at the end, it will become a 27-carbon compound, which is actually the precursor of the steroid hormones that we have. And that is, of course, I'll draw it in green to indicate that it is an end product, cholesterol. So from cholesterol, we use it as a precursor for sex hormones, glucocorticoids, and mineralocorticoids. Now, when we have fatty acid synthesis, what happens is that you have 2 carbons here, then you add a malonic acid. Malonate is 3 carbons, so you have 5 carbons, but immediately you reduce 1 carbon, so you end up with 4. So in every time you add a malonic acid, you in turn, so this is 2, add 3 minus 1. Essentially, you add 2 carbons, then plus another malonate would yield 6 carbons, then another would yield 8. So every time you add a malonic acid, you add 2 carbons. But then again, the starting point in fatty acid synthesis is acetyl coenzyme A. And actually in this one, naturally, it commonly stops when you get to 16 carbons. And the name of that fatty acid, saturated in nature, is palmitic acid or palmitate. And finally, acetyl CoA can actually be used in the synthesis of what we call as ketone bodies. What are these ketone bodies? There are 3 specific ketone bodies. First one is acetone. The second is acetoacetate. And the third is beta hydroxy butyric acid. So I'm going to draw them. This is acetone, 3-carbon compound, acetoacetate, and this is gamma. alpha, beta. This is beta hydroxybutyric acid. So comparing the three of these, the acetoacetate and beta hydroxybutyric acid are both 4 carbons, so meaning that acetone is the smallest. But in any case, all of these 3 ketone bodies are progressively deleterious to the body because these ketone bodies are actually acidic. And guess what? Since it resides in blood, it could actually induce acidemia. Alright? Or it would lower the pH of blood, and you don't want that because remember, blood and the enzymes in blood operate at a maximal or at a certain pH range only. So if you go beyond that, it will produce what you call as acidemia due to ketone bodies. The name of that is ketoacidosis, and that's a very problematic condition. Another condition that could come out of this is ketonuria, which means presence of these ketone bodies in urine. Could be indicative of any underlying disease. Alright? For example, ketoacidosis could actually be an adverse effect of diabetes mellitus 1. Alright? Specifically diabetic ketoacidosis. In short, it's a very bad condition. Alright? And finally, ketosis is generally a state wherein the body now uses ketone bodies as a source of energy. Alright? So these are conditions arising from ketone bodies. So yeah, that's how special acetyl coenzyme A is. Enough to cover like 6.5 minutes of your time.